Okay, welcome everyone to TAM Lab number 63. Today we've got Dean Lewis joining us. He's going to be going through a session all around Horizon on VMC on AWS and things you need to consider and some of the constraints, things like that. So I'm going to stop my sharing and I'll hand it over to Dean.
Thank you very much, Steve. Okay, so the obligatory Zoom check of can everyone see my screen okay?
Yep, looks good.
Perfect. Okay, so we're going to kick off with a few slides and then I will actually take us into the lab environment as well to kind of show some things we've talked about, and then also have to answer kind of Q&A as we go along through this as well, so please don't hesitate with your questions. And so a little bit about myself. I'm mainly focused around networking, virtualization, and funnily enough, the UC space. I was a keen scuba diver. At the moment, it's a little bit hard. I'm currently trying to get my daily steps above 100 currently. You can find me on VEducate.UK and also on Twitter as well. There's a couple of links that are detailed in the slides as well. You can find all of that information at the easy link of vexpert.me/VMC Horizon. So we're going to go through the overview of Horizon and the options available today, the recommended architecture and also the architecture of the lab environment we'll look at, the feature support, which is very key, and then really the considerations part, which is around managing the platform, networking and security, and then really final considerations as well, if you're looking at productionizing Horizon and running it on VMC, or in joint with an existing Horizon that runs on your on-prem environments as well. So first and foremost, I think we need to start off with a little bit of positioning. VMware Horizon 7 running on VMware Cloud and AWS is not desktop as a service. So on the left-hand side here of the diagram, we have the explanation. It's still the same IaaS model that you understand, know, and love when you have an on-prem format. VMware Cloud and AWS is a VMware managed service, so you don't have to manage the underlying host, storage, network connectivity. So you don't have to worry about that from a day-to operations point of view. But when you build your VMs and your infrastructure on top of that, like your Active Directory domains and getting to the point of Horizon 7, you will have to fully manage that yourselves. This is in contrast to the Horizon Cloud offerings, such as on IBM SoftLayer or on Azure, known as Horizon Cloud, where you have a VMware managed service, which is the underlying platform itself, which includes the Horizon Cloud management parts itself. So that would be the user login, the provision side of it. Essentially, on the managed desktop as a service, you bring your desktop image to that service and then tell the environment where to deploy, which maybe data center from IBM to use, or which region of Azure to use as well. So that is the stark difference between the two. And in today's call, we're going to cover on the left-hand side, which is Horizon 7 on VMware Cloud and AWS. In terms of the available architectures, today's environment, we're only going to look at a deployment which is wholly hosted in VMC itself. However, we do support cloud pod architecture. So cloud pod architecture is the way to scale out your Horizon environments across multiple data centers, multiple locations and geographies. Ensure that there's a connection between them so that the user gets a consistent feel when they log in. Designing such architecture does take into consideration the need to set up things like global load balancing and IP address routing between environments. But once you've achieved that, you can, for example, set up a on-prem Horizon environment and then extend that out using cloud architecture into VMC. So that's really great when you need to really span up that Horizon environment. At the same time, though, it is fully supported to just host your Horizon environment in VMC itself. In terms of feature support, especially for those of you that have used Horizon before, there are a key number of features that are unavailable in VMC. So for example, the ability to use view composer linked clones. We don't support security servers, which is the Windows-based installation for your DMZ architecture. We would rather that you use the Unified Access Gateway, which is a hardened Linux appliance provided and managed by VMware. There is also things that are not available, such as VVols. So as you may or may not know today, we don't support VVols in VMware Cloud and AWS. We only have the vSAN architecture there. So therefore, if it's not available on the platform, it won't be available for support within an Horizon deployment. We do support the vRealize for Horizon monitoring. You would have to bring your own VROP solution to the environment to set up the vRealize for Horizon adapter, but that is supported. Okay, so if you go over to our VMware and AWS main product page, you will actually find reference architectures for various different solutions, and we do actually offer a reference architecture for Horizon running on VMC. As you can see in this particular diagram, it covers the ability to span out an on-premise customer deployment, extend that to AWS, and even consuming AWS native services, which we'll talk about in the next slide or two as well. In today's infrastructure, we're going to kind of look at a cut down version of Horizon that we've set up our Active Directory in the VMC environment, along with DHCP, DNS, local file shares, and we're using Dynamic Environment Manager, previously known as UEM, for managing the profiles of users as well. It's a really simple environment, but one of the key things we've done here as well is deployed ABI load balancing technology as well, which we'll get to in the networking section. But I think really for anyone who's used Horizon in the past previously, the only real difference between standing up Horizon in your on-prem environment and standing it up in to be used in a VMC environment is a little tick box, which is highlighted by the red arrow at the moment. So you still connect to the same. You provide a vCenter address, the same as you would on an on-prem environment. You provide your login details with the right permissions, but you click that little box, and that lets the Horizon connection brokers know that there's restricted feature support and also restricted permission sets available in VMC. And if we go through this diagram, it's an overview of the lab environment that we have set up today. And it's really simple. All users connect through a FQDN that's available publicly. We hit the NSX Advanced Load Balancers, also known as ABI Networks. That then distributes us to two unified access gateways, who then will connect us to our connection brokers. We'll look at Active Directory for that user authentication. And then once we're logged on into an RDS farm session host, as we've got set up today, then users will also be mapped to their user shares as well. So we've really replicated kind of a smaller version of a customer environment. So before we stand up any of the Horizon components, some of the things we really need to think about when we're consuming any VMC platform, even if we're not going to use Horizon, is identity management. So proximity to Active Directory is key. We need to at least consider having a read-only domain controller stretching from the private cloud. And we also need to set up sites and services correctly. So that's the ability for Active Directory to understand the network that your machine requests are coming from and send you to your correct local domain controller as well. It's all well and good setting up a domain controller in VMC itself, but if you don't have, if you log on into the infrastructure running in VMC, but sites and services send you to your local Active Directory server across a WAN link or even a VPN tunnel, then you're still going to find that your end user experience is very, very slow, especially from a logon perspective. File shares is probably the biggest thing that an end user is going to notice in terms of an experience. So again, proximity to the user's desktop is key. For user documents, consider using technologies like Microsoft distributed file systems if you're stretching the file services between on-prem and VMC. But we do also support native AWS features. So for example, you could look at the Amazon FX for Windows file server, which is a way of distributing them files up into Amazon and then sharing them out into the various Amazon services as well. For user profiles, we recommend that you use the Dynamic Environment Manager, previously known as Unified Environment Manager. But you can also support native Windows features, such as the Microsoft FX Logic, which is a virtualization of that user profile context for systems as well. One of the biggest mistakes that I've seen in the past with customers that have deployed Horizon, regardless of whether it's in a cloud service or across multiple data centers, is really that lack of understanding between where the users' files are, where their virtual desktop will be located, and where they're actually logging on from their endpoint itself. And then finally, image management is a big piece that comes up quite a lot. So at the moment, VMware Horizon doesn't support the use of content library within vCenter. So you really need to think about, if you're stretching from an on-prem environment, how do you look after your golden images? How do you replicate the setup from on-prem into VMC? Do you update them in lockstep? So that means you have two separate virtual machines that you need to keep on top of. Or do you keep a master golden image in one single vCenter? And when you've updated that, you then transfer that into your other vCenters so that they can be used by your different Horizon setups. For me, when I was really building out the Horizon lab, the key parts that I was coming through more so than anything else was the networking and security. So at a minimum, we need to set up 2 LAN segments, ideally 3. So we need the internal LAN itself, where our Horizon service is going to live, our DNS, our file services. We then need a DMZ network, or if you're going to be really security conscious and looking at production, then you'd be setting up 2 DMZs. So that would be a DMZ that's external on the front end connection, and a DMZ on the back end that then routes through into your internal network. In our basic setup, we've essentially created 1 DMZ network, the Horizon RDS network, so that's going to be where our desktops run themselves. And we've also set up a network for load balancing services. Moving on to load balancing services, VMware Cloud and AWS at the moment is a bring your own load balance solution. So there's a number of virtual load balancing solutions that would work on VMC. Some of these include, but not limited to, using, again, AWS native services, such as AWS Route 53. So you could use that for your global load balancing if you wanted to implement cloud pod architecture. You can use the AWS Elastic load balancers, which is the diagram we've got here up at the top. So your user activity would come off the public internet into the AWS native services and then be routed through an internal AWS VPC into your SDDC itself. Or again, you could use other VMware services such as the NSX Advanced Load Balancer. So you could run those same virtual machines, which we'll look at as we come off these slides into the live demo side of it. The users would come off the public internet, terminate directly on your cloud gateway service for your VMC instance, and then the traffic will be held within your SDDC itself as well. So kind of really the 2 considerations between there is, how do you want to route traffic in and out of your network? Do you want to go through the native services of AWS, or do you want to run and manage all of them services yourself within your own SDDC? The next consideration from a networking point of view is DHCP options. So VMware Cloud and AWS is built on top of NSXT technology, and we do offer basic DHCP services, but you may find they're limited in the scope and options that they make available to you. So it is supported to run your own DHCP server within VMware Cloud and AWS itself. We can allow that to be a DHCP relay on the segments itself to your server. And you could easily run this only on the server and subnet that you need to run it on as well. So you wouldn't affect all the traffic or segments that you've set up within VMC, which is how we've configured it today. One of the reasons we did this in the lab was just to give us a little bit more control. So when you set up a DHCP options or server within the native offering of VMC itself, you don't get control of being able to delete the leases that have already been handed out. You do have to wait for those to age out. Whereas when we control it through our Active Directory server that we set up and installed the DHCP service on, we can control those lease and set, for example, the lease hours down to 4 hours, which suits ourselves a little bit better for building up the environment and destroying it quite quickly. Moving on to the security side of things, there's 2 key components in terms of firewalling within VMC. We have the gateway firewall, which looks after north and south traffic. So that's Simple in the fact that it's everything that leaves the cluster, so your SDDC to the outside world and back in again. So you have two gateway firewalls. You have your management gateway firewall. So this looks after the management networks, things like your vCenter, the ESXi host. And if you set up anything like a managed HCX service for migrating VM workloads between your on-prem and your cloud environment. But essentially, as a user, as an administrator, you're going to be focused on this compute gateway firewall, which is where you set up all of your network segments and are able to run your virtual machines in the space there. So when we set up our DMZ, we're going to create gateway firewall rules that allow traffic through from the outside world into our compute gateway and then into our DMZ network. However, there is a problem. Because this only looks at north and south traffic, we do need to consider east to west traffic. So that's where we bring the distributed firewall into the mix. Oh, sorry. And that distributed firewall gives us the ability to zone off our virtual machines so that they cannot talk to one another. So once we've created our routed segments so that they hit the gateway firewall and go out, we then need to use the distributed firewall to block traffic so that we can really create that DMZ zone, which we'll go through in the live demo in a moment. Okay, so any questions or queries so far? Okay, I'll take that as we're all good.
One quick question.
Yeah.
I did notice that you were talking about VMware Horizon is not supported in the cloud, correct?
Sorry, so to redefine that statement, we don't have a offering for the vRealize Operations Cloud Edition.
Right.
At the moment, the supported setup for that is to deploy your own managed instance of VROPS and then install the management pack, which comes with the Horizon adapter.
Right, I'm with you. Thank you.
No problem, thank you. So if we look at our VMware Cloud AWS console first and look at the network and security tab, you can see here we've set up a handful of segments. And these are just routed segments. We don't have any DHCP set up on these because we don't need them. Bear in mind that for our environment, we have set up an additional adapter on our AD server and we've configured the DHCP role there, but it only offers DHCP addresses to anything in this network. It doesn't affect any of the other segments that we've set up. So we've really locked down that DHCP configuration. And if we just open up the setting here, you can see it's a routed network. We do have the ability to change it. So in VMC, you do have some different network types, but essentially we want the routed networks. Anything else would actually disconnect our environment. We've also set up NAT rules. And these NAT rules are really simple. So we're taking a public IP address, which we've gained by going into public IP addresses and clicking create new. And essentially then we map that back to our internal service. So this internal IP address here is our ABI Networks IP address. And this is a load balance, which we'll see when I touch on the ABI Networks setup shortly. And then from there, the ABI Networks controllers are going to route that into the network where it needs to go as well. When we look at the gateway firewall, as it loads, unfortunately, it looks like I didn't pray quite much to the demo gods to get everything working quickly. So I'm just going to filter on this table as well, just so we bring the number of rules down there. So on the gateway firewall, I essentially have two rules. The first rule is to allow any traffic coming into my unified access gateway. However, that again is the load balanced IP address through ABI Networks that we'll go into. I've locked it down, so we're only interested in the Horizon services through the UAG. So we've got a lockdown environment there. We're allowing the traffic, and in today's environment, I'm not logging any of those packets that are coming through. However, we will also have a quick look at logging capabilities through the NSXT firewall itself. But essentially the biggest configuration for me when I was setting this up was really looking at this distributed firewall. So as I mentioned before, by default, because each of those segments that we've set up are routed, it means that because the traffic's internal, I can get to and from my DMZ without any implications. I can also get to any other segment that's set up as well. So in the distributed firewall rule, we have our various categories set up. So these are kind of working like a normal firewall where you set up your rules and the rules are processed through NSX as your traffic goes through them from top to bottom. So we have the ability to set up kind of rules at an Ethernet level, emergency, infrastructure, environment, and then application. So in today's environment, I'm really looking at the application side, but if you are interested in kind of how we look at those rule categories, then in the VMC documentation available publicly, we do actually describe the architecture behind those distributed firewall rule categories as well. So it is something really worth thinking about as you start to build up your complex firewall rules in a VMC environment. And arguably there should be some break glass rules that you've got set up, especially at the infrastructure and the environment level, to make sure that you don't accidentally lock yourselves out of being able to access your Horizon environment, but also your management components, such as your Active Directory servers that run in this environment. Okay, focusing back on the application rules that I've set up today. So I've created a section, and this section just holds a number of rules together. The sections are hierarchical. As I mentioned before, we process from the top down. So as you can see, I've just called this one nice and simply the Horizon Unified Access Gateway. And first and foremost, the first rule we have in here again is replicating from that gateway firewall. We're then going to start processing distributed firewall rules again. So we need to ensure that we allow the traffic, again, coming from the outside, to our unified access gateway objects on the ports that we specified. We then need to also allow our load balancing servers to then hit our UAGs themselves. We need to allow our unified access gateways to then communicate to our connection brokers internally. So as you can see, on each of these rules, we've also locked down the rules that they're on. And as we go through this, at the bottom, we then tail that rule with 2 deny rules. So what we're doing here is we're denying any connection going to our unified access gateway objects, because again, these sit in our DMZ subnet we've set up. And we also deny any connections leaving the UAG. And essentially that acts as a normal firewall, which is anything that is not specified is going to be blocked by default. And the reason for this is because by default, the rules in VMC are allow all at the moment. So if you do not set that deny rule, then the traffic, even if it doesn't match any of these existing rules, is still going to be allowed in the environment. So we're just going to move into the into another interface, which is the VMware Realize Log Insight Cloud. So at the moment, as it stands, if I open up this rule, we should still have logging turned on. He says as he waits. Yep. So we've got logging turned on these rules here. And what we should see is I've not allowed NTP from or to the UAG services. So when they try to make a connection to my NTP services, we should still see some failures. I can see actually on the last demo, I have actually added it there, but we can also look at this login again in a second when we go through this. But if we go to Log Insight Cloud, as part of your VMware Cloud AWS, you will get the basic service offering from Log Insight Cloud, which allows you to ingest those NSX logs, and you can look through them. If you do pay for the service as well, then you get the ability to set up additional dashboards and content packs as well. But if you don't pay for that, then you can still browse through all of the logs. So you can see at the moment, we have a number of firewall rules that are being blocked. If you have multiple sources going into your Log Insight Cloud, then we can also change this log type and set it to NSXT firewall. And I'll set that to the last 10 minutes. And hopefully there's still some content in there for us to see. And then we can see the reasons why these rules are coming through as well. So really, really powerful. So I know at the moment that these are requests coming from part of my environment up to my AD server. And again, you can start to really kind of dig down into the environment and start to use matches based on these logs as well. So it's a really quick and easy way to kind of troubleshoot sometimes when you have problems. And this obviously will also work if you set the logging on allow rules as well.
So you really want to make sure that your VMs that are out there in the cloud are talking to your local AD, as an example, as opposed to going back to on-prem.
Yeah, exactly. So you can sometimes see this through the rules as well, you know, where that's going through. Ideally, what you want to be doing is setting up that sites and services so that your Active Directory servers are linked to the correct network segment that they're placed in, and also the other network segments that they should talk to. Sites and services within Active Directory is really the way to give Microsoft AD that geo-awareness of various locations. Otherwise, what's going to happen is your clients, especially your virtual desktop services that your users are logging into, when they're looking at authentication, for example, they look at that against the domain name. So if you look up, as an example, vmware.local, you're going to get a list of IP addresses back from your DNS server.
Right.
But you won't know which one of those is local to you straight away. So as soon as you make that first request to your AD servers, for example, you're going to be told, hey, you need to speak to this AD server because it's local to your subnet or local to your location.
And I realize a lot of this is outside of Horizon, but I'm with you.
Yes, but again, you know, getting the infrastructure fundamentals right first time obviously saves you a lot of problems when you start to set up Horizon. Okay, so we are going to move into the Horizon environment itself and just kind of talk through some of these things that I mentioned before. So if we look first and foremost at the vCenter that is linked to our SDDC within VMware Cloud and AWS, it looks and feels the same as any vCenter that we're used to or have managed for the last however many years you've worked in IT for, which for me is great. It's the selling point for VMC. It looks and feels the same. Your VMs act in the same way that they do when they're on-prem, and you don't need to learn anything. So really, at the same time, when you're demoing this side of VMware on Cloud and AWS, it's also quite boring because it's the same as what you're already used to. But here in my environment, I've set up a couple of resource pools just to make sure that we don't have any negative effect on my infrastructure components. We make sure that those resources are set to high. So we have our two connection brokers, our two UAG servers. We've got the NSX Advanced Load Balancing PC setup as well. So that's a single controller and two service engines as well. Each of these run on the different networks. On the ABI Networks side, if I look at this virtual machine object, you can see as well that we've connected that into our different network segments as well. So we obviously have the management segment to connect to the management interfaces on the ABI Networks, the load balancing IP address segment that we talked about earlier, and obviously connecting into the DMZ as well. For our RDS servers, because our desktop pool is essentially an RDS farm today, it's just connected to that one network as well. So I'm actually logged in for this part of the demonstration into one of the RDS servers through the Horizon environment itself. So I've authenticated into Horizon. It looks and feels the same. So if you want to see that quickly, if I go to our external web address, I'm going to be asked, so I've already logged in there. So if I log out, this might cause a slight problem in a second for myself. So we've set up a kind of just a basic message for everyone before they log in that they accept. You enter your details, and then you're going to be given access to everything. And again, from this point of view, from end user experience, this looks and feels the same as if that Horizon environment is on-prem or it runs in somebody else's managed cloud, such as the VMware Cloud and AWS. It's going to request my desktop back again. So if I log in to my environment, from the administrative side, I can spell And if I scroll down first and foremost, and we look at typically what the settings you're going to look at when you first start to build this up, we essentially deploy the connection brokers and we install the executables for the connection service. The rest of the configuration is done in the administrative consoles. So first and foremost, you're going to want to add that vCenter server itself. And if I edit the existing vCenter server, as it loads up, we're going to see all you're doing is the same as you would do on-prem, which is provide that vCenter server address, your username and password, and then you click that box there for the VMware Cloud AWS, and that tells the Horizon environment that it's built in VMC. It is a restricted model, and there's going to be certain features that are not available. Every other option that you've seen before in Horizon is going to be available. So configuring operations limits. If I go to the top, we won't be configuring a view compose service because it's not supported in VMC. You would actually find you start to cause yourself some problems if you try to manually circumnavigate that environment. We don't support the Horizon Storage Accelerator because we're using vSAN as a managed service up in VMC. And then finally, we have the ready to complete page, which is just going to confirm it as if we've gone through the wizard itself. From a connection service point of view, again, each of these connection servers are going to look and feel the same. There's no additional configuration that you need to look at from that point of view. You're going to need to set up your instant clone account because we only support instant clone technology for deploying virtual machines in VMC. And the instant clone domain account essentially then is so that we can add those instant clone machines into your Active Directory domain itself. And then when we look at creating a pool, so because we're using the RDS farm technology, in Horizon, you would actually create your RDS farm first and then enable a desktop pool on top of it for the users. If I edit my existing pool once again, we set up the pool as we would. We define our display protocols. One of the key things to kind of really think about on here as well is in our environment, we've locked it down so that we're only using the BLAST protocol because that's the protocol of choice and recommended by VMware now for performance and the best end user experience. PC over IP as a display protocol is now becoming legacy. So again, if you don't allow that, if you, for example, don't restrict what protocols users can have connecting to their environment, but then you block it on the firewall rules, for example, your users may be connecting by default using PC over IP or even RDP into their environment and find they will get disconnection messages. And that's literally because you've got the firewall rules wrong. And it's just really simple and easy to make sure that you understand the right settings and whether or not you need to stop your users from selecting that protocol when they connect. We have the typical settings for launching sessions and what happens on timeout. And then again, as you can see in this example, I'm actually connected using the HTML client. So we need to also make sure that's enabled on our desktop farms and our desktop bills as well. If I go to the top again and go through the various tabs. So if we go to provisioning settings, we enable on provisioning, stop on an error, create your farms. We don't do anything different in here in terms of for compose services because they're not available. And in our vCenter settings, we have the ability to change our parent VM, look at the snapshots, look at the location of where it's based, and then also where are we pushing this image to in our environment as well. So for example, do we use a particular resource pool that we want to maybe lock down our images on as well? If we look back at our vCenter at the moment, I have a resource pool called Horizon, but what you may want to do, for example, is have a separate resource pool for your desktop services when you deploy them as well. So you may have a Horizon infrastructure resource pool where you keep your connection brokers and unified access gateway servers, and then a second resource pool may be called Horizon desktops or Horizon pools, which then holds the deployed instant clone virtual machines as well to ensure that they're getting their resources at the right time. Okay, We'll just have a quick look at the ABI Networks setup as well, because that's the load balancer of choice in this particular lab environment. And it's always really good to show some of this side of it as well. So we've really set up 3 virtual services, and there's a whole great run-through guide from start to finish on the ABI Networks user documentation website that shows you how to set this up for a Horizon environment. And essentially in the Horizon environment, it doesn't matter for ABI Networks whether you're running this on-prem, whether you're running this in VMC, the configuration is the same, which is really great. It keeps consistent configuration. But at the same time as well, ABI Networks can also allow you to set up that global load balancing so that you're able to load balance sessions for between on-premise servers and on-premise Horizon environment, and also VDI desktops that run inside of a cloud environment as well, whether that's VMC on AWS, or even maybe even the desktop as a service offerings that we talked about at the start of the session. So for our load balancing in this particular environment, we have 3 virtual services. We have essentially 2 groups of virtual services. So we have our internal load balancing to our 2 connection brokers. So that's hitting that authentication piece when we come internal to the network. And then we have a layer 4 virtual service and a layer 7 virtual service, which is essentially managing the load balance connections coming into the environment through that public IP address when the users go to the FQDN, either through their HTML browser or they're connecting at a layer 4, which would then be something like the PC over IP, or a direct blast connection as well using the Horizon client itself. In terms of the Horizon client, if I bring it up on my machine, I think everybody will know what I mean there straight away. Essentially, you've got those 2 options for connectivity, directly through the HTML5 or through the client itself. For the applications itself, they obviously back off to a virtual service. We can see we've got some connections coming through at the moment, which is essentially myself just using this environment through the lab. And if I click into this service, because we can see that the health is slightly degraded at the moment, one of the great things with ABI load balancing is we get analytics and health straight away through the service. So this is kind of one of the key features to use ABI Networks versus some of the other options out there in the market. So we can see straight away that before this session today, before I started, I was playing around with the environment. I was trying to cause some outages just to actually throw some health data in here at the moment. I think I've had a little bit of a negative effect on here because, as you can see, it thinks that the app response time is 17 hours at the moment. And as we know, that can't be the case right this second, because I'm actually using the image itself through the VDI environment, and we know that it's more responsive than waiting 17 hours. But as I kind of move through this environment, we can see that this analytics kind of changes on the fly, which is really great. So straight away, you can kind of see where the health sits within your virtual services. And if I go into the health tab itself, we can also see how this health score is built up. So we can see that the only thing really affecting that health from being 100% is that performance score has dropped off a little. And then if I look through the top factors affecting health, I know that this particular metric is talking about ABI Networks looking at the client experience. So what it's saying here is essentially if a client is connecting through this particular virtual service, so for us we're consuming the BLAST protocol over HTTPS, there is a little bit of intrusiveness in there, so the experience may not be as great as it possibly could be. For example, I may experience that I move my mouse and it doesn't quite move straight away. Now, I know the reason for this particular health issue is because I was vMotioning the load balancing services all around the network. So I was causing a little bit of network instability on them as I was moving them around the network. And I was also taking off some of the servers in the pull group as well before we started this session. And then really if I just kind of go to pools as well. So one of the things that ABI Networks can look at as well is not only just the health of the service that's being served, but also that back end. So if we've got a pool of servers that are underpinning that, we can see here we've got 2 UAGs in each of these and 2 connection brokers. What's the actual health of those services as well, which would then have a knock-on effect to serving the virtual service itself. Okay, so we've kind of really gone through quite a lot there. I guess I really should have started off the session by saying we're not going to kind of cover how to install Horizon and configure it, because essentially the same user guides apply when you're using Horizon in VMC as it does on-prem. But really you kind of think about some of the considerations in terms of networking and security are really key, and also that load balancing service. But if I go back to the presentation now, there we go. And I just really want to kind of finalize on some final considerations as well that we've seen when we've kind of looked at the different use cases, and whether this is, you know, customers implementing these types of services with VMware or on their own. So if we think about maybe the considerations of you're using the Horizon offering in VMC so that you can evacuate your current data centers. So some of the use cases we typically see from customers, for example, is their current Horizon environments are running on aging hardware. So they really want to kind of be able to spin up a new Horizon environment very fast, and maybe don't even want to manage hardware going forward as well. VMC is obviously a perfect fit for that, as is other cloud providers such as IBM, Rackspace, for example. You need to think about, first and foremost, are you going to be using the cloud pod architecture? So do you want to be able to load balance user services from accessing the on-prem environment at the same time as the the cloud version? Or are you going to run separate Horizon instances? So maybe you're going to go around your business and take groups of users and then just proactively move them so that they only consume the new Horizon environment running in VMC. Once you kind of understand that at high level, we then need to start to think about what is going to be your constraint in your design. So how many users will you need to support? There are obviously, like building a VMware on-prem environment, there's maximums that you need to think about. There's going to be soft limits and hard limits for those maximums. Some of those soft limits you can have increased by opening up a support ticket with VMware. So for example, the amount of SDDCs that you can spin up against your organization by default. You're also going to hit hard limits as well. So for example, how many clusters can you build within a particular SDC, and how many SDCs can you connect together? We then need to think about more around that EUC space. So the desktop to host ratio is going to be affected by a number of things. It's going to be affected by the size of the virtual machines that you're running to provide desktops to your users. If your users run intense workloads, then that desktop to host ratio is going to be a lot lower, which means you will need more hosts in your environment, which then has a knock-on effect. If you hit the host limits per cluster, you're going to need multiple clusters. And then again, if you hit the cluster limit per SDDC, you may need multiple SDDCs. One of the good things that I've seen in terms around of thinking about users and whether or not they're going to run intense workloads, typically the other consideration as well is your users going to be running in maybe a thin client which supports multiple monitors as well? If you're going to be using multiple monitors for your endpoint, then that's obviously going to need more graphical compute power on the desktop, on the VDI side that's serving that up. And then finally, your networking connectivity. So what's your connectivity going to be to VMC? It could be as easy as you have a endpoint connection which is over a public IP address to an FQDM. Maybe you need to set up a VPN connectivity to your on-prem environment so that users can either access the desktops or just access their files. So are you going to be implementing something like IPsec VPNs? If you do that, IPsec encryption is going to add an overhead on the traffic. So you really need to then think about the traffic that's going to be coming through that tunnel all the time to your on-prem environment, and whether or not your on-prem firewalls can handle that additional load. If you may decide to implement direct connect technology with AWS, so that's the native direct connection technology. So you would go out to an MPLS provider, pay to use their MPLS environment. They have a connection that's direct up to AWS. So then you bring your latency down, you can get a higher performance pipe or connection through to them. But as with anything, that's going to be a high cost to do that. And you would always still pay for that ingress and egress traffic in and out of AWS as well when you hit their VPCs. So that's some of the considerations you really need to think about, especially from a networking point of view. But if we then kind of think about some of the resolutions that we can look at, quite a few of these things, especially when you start to hit limits, are going to be fixed by scaling out across multiple SDDCs. So if you needed to use VPN tunnels through the transit gateway of AWS, because that's where we're going to be tunneling to get to the outside network, we look at this diagram here. The way that the networking works in VMC itself is kind of quite simple, but also can be quite complex. We have our on-premise network. When we create a VPN tunnel or connectivity up to VMC, we actually are always going to transit through a virtual private connectivity of AWS itself, which is a transit VPC. That transit VPC will then direct traffic into the VPC that's been set up for your SDDC itself. Or you may be hitting other VPCs that have been set up for your AWS native services that you already have running. So the first and foremost, you kind of really need to think about that, where the traffic goes, what it hits and how it gets there. But when we look at the SDDC itself, if we're hitting maybe limits in terms of VPN tunnels and overhead, then we can easily alleviate that by just spanning out into multiple SDDCs, because then we have separate VPCs that we can connect to and run those VPN tunnels over. At the same time, if you're spread out in multiple SDDCs, you can also spread that load in terms of users and also get a better maybe desktop to host ratio across multiple clusters in different SDDCs. But once you've done that, you then start to scale out the operational side of things from a management point of view. So that's then again where you may need to look at the use of something like cloud pod architecture, because that then gives the user a seamless view of being able to log into one endpoint, and they will be passed through to the correct backend infrastructure wherever that virtual machine is running in whichever SDDC, and they don't see any of that, which is partly comes back to providing a great end user experience. And that really kind of covers off my talk today. So thank you for everyone that's been on the call and listening. If there's any questions, I'm happy to take them now. Okay, silence is golden. So I'd just like to finish off. For the links that we've been through and some of the information that we've talked about today, you can go to the vexpert.me/VMC-Horizon, and that will take you through to all of these links that I've listed below, which takes you through architectural designs, considerations, the use of AVI load balancing, for example, as well. But once again, thank you very much for the opportunity to present on TAM Lab. Really appreciate it. Thank you for everyone that's taken part in the call today as well.
Awesome. Thanks, Dan. If there's nothing else, I'll let you guys go. All righty. Well, have a good rest of your day and a good weekend. Take care.
Thanks, Steve.
Thanks, Dane. Bye.